Assignment 1 and 2.
I switched, like I stopped.
Oh, you
stopped the course.
right from 136 or 135 to here. Yeah. Talk to the ISAs afterwards. I'm not entirely sure what happens there. 'Cause, yeah, I don't deal with that part. Sorry. Okay. Let's begin. Okay. Is this good? Yeah. Everyone can hear me? Yeah? Okay. Okay. When's the difference? That's a while away. Okay. Give me another 30 seconds. I'm just trying to get something loaded on my computer. Okay, let's begin. So, up till now, we've finished the first three modules. We're on module 4. We've covered, in module 1, we covered the data types, natural numbers, integers, and numbers in general. We saw how to trace programs, how to go from a mathematical expression into Dr. Racket, and then go from a Dr. Racket expression into one value that cannot be simplified any further. Then in module 2, we saw the design recipe, we saw the contract, the purpose, examples, requirements, your code, your implementation, and then test. We also saw the string data type. Module 3, we saw the Boolean data type, we saw conditionals, and we also saw the symbol data type. Now, module 4 is when we're going to be introducing a new kind of data type called the structured data type. And up till now, like I said, this course is not really that hard. All the stuff you've been introduced to in the first 3 modules should be kind of straightforward. And the stuff we're going to get into now is actually going to be a little bit more challenging. And this stuff is actually very essential for you to understand what's going to happen next week, which is recursion and lists. And you know how I keep saying, starting next week, starting module 5 is when the course picks up? Well, that's next week. And for you to understand that stuff that we're going to be covering next week, you really need to make sure you understand what's happening this week, because it's kind of like an introductory to what's going to happen next week. And what is this week? It's the structures. We're talking about one more data type called structures. So, what is a structure? Well, to understand what a structure is, we need to understand what a data type is. Up till now, we've seen a few kinds of data types. We've seen numbers, strings, symbols, and booleans. What is a data type? A data type is essentially some way to hold a piece of information. And this information that we're holding can change. It can be a number, it can be a word, it can be a symbol, it can be a boolean. It can be many different kinds of things. Okay? A structure is a data type in the sense that all it is a way for us to store information. But the information that we're going to be storing, up till now, all the information that's been stored has been programmed by Dr. Racket. Numbers were given to us by Dr. Racket. Strings were given to us by Dr. Racket. Symbols and booleans, they were given to us by Dr. Racket. These data types were provided to us. But now we can make our own data types. So that's what a structure is. It's our way to create our own data types. Now what does that mean? That sounds pretty confusing. What does it mean to create your own data type? Well, let's see. Are we on the doc now? Okay. I don't think I have any more empty pages here. Oh, this is good. Okay. So, a structure, earlier on I said a structure was a data type. A structure is not actually a data type. A structure is a way for us to create our own data types. Okay? So, there's a new keyword that we're going to be introduced to, and it's called define struct. So, it looks like this. Is this visible? This looks like it's visible. It's called define. Very similar to how we opened it previously, but now we're going to have a define dash struct. And this is telling us we want to create a new data type. Okay? And now, what's going to happen afterwards? Whatever we put here is going to be the name of the data type. Okay? So, I'm going to give an example. Let's create a student data type. Okay? So I'm going to call it student. Okay? So up till now we've had data types like symbols, booleans, natural numbers. We are now having a new data type called student. Okay? Now, you might ask, what is a student? We know a string is something that's enclosed in two quotations. We know a number is something that's written as a sequence of digits followed by one another. We know a symbol is one quotation followed by several different letters and numbers. What is a student? Well, because we're making it up, we have to actually define what a student is. So, what would be some properties that would go within a student? Well, presumably all students have names. So, let's have one field within our student be their name. So after you have open bracket define struct and the name of the data type, you're going to have an open bracket, and then you're going to have all the different fields that are associated with this student. So let's have one called name. Okay? We'll also have one called age. Okay? We'll also have one called gender. All students have a name, an age, and a gender. Now we could add on to this. We could make this a lot longer. Students also have a height. They also have a list of classes they're taking. They have a bunch of other stuff. But because we're making the data type, let's just keep it really simple for now. Let's just say a student is something that has a name, an age, and a gender. Okay, we're not done. We still haven't fully defined this data type. Because we've defined what a student is. We said a student is something that's a name, something that's an age, and something that's a gender. But we haven't even said what a name, an age, and a gender is. So now what we need to do is we need to define what a name, an age, and a gender is. Okay? So in comments, you're going to define what the different fields are. So we're going to say name is, okay, so this is not exactly how we're going to do it, but for now, let's just bear with me. This is how we're going to do it for now, but later on today, I'll show you how to actually do it. What we're trying to do is define the three fields within our structure. So name is str, age is nat, and gender is symbol. It could be either male or female. Why is it not a string and why is it a symbol? Well, because gender is fixed. It's either male or female. There's no changing gender. There's no, well, I mean, there's no changing gender. Okay, it's a symbol because there's fixed amounts, and yeah, okay, that's all I'm going to say about that. But so essentially, now we've defined our student. A student is something called name, something called age, something called gender. What is name, age, gender? Name is a string, age is a natural number, and gender is a symbol. Okay? Let's define another structure. Or sorry, not another structure. Let's define another data type. So define struct is our way of saying we want to define another data type. Okay? So let's define a data type for Let's see, what do I want to do? You can define a data type for pretty much anything. Let's define a data type for, let's just say country, okay? So, country. Okay? So, what should a country contain? The continent it's in. So now let's just start off with the most basic one. A country should also have a name. Okay? A country should have like population. A country should also have the continent it's in. So continent. Is this how you spell continent? Is that right? Continent. Yeah? Okay, cool. My spelling is really bad, as you guys can tell. Name, population, continent. What other fields can we have within a continent? Yeah, so we can have a Boolean called developed or not developed. So, and because it's a Boolean, it's going to end in a question mark. And then same thing here. We're going to say name is str, population is nat, continent is symbol, and developed is bool. Okay? So notice what we're doing here. We are making our own data types. Now, what we can do is, well, let's just think of what we did before. We had functions that consume numbers. We had functions that consume strings. We had functions that consume data types. Okay? So now we can have functions that consume our own data types. So we can create a student, and then we can have functions that consume students. We can create a country, and we can have functions that consume countries. Okay? You have a question? Developed, so the reason I put a question mark at the end of developed is because anytime you have a Boolean value, we call it a predicate. So last class we talked about predicates, and what predicates are anytime you have a Boolean value or a Boolean function, you want to have a question mark at the end of it. And that's our way of determining or defining what a Boolean is. There's no, it's not part of the code, it's a style thing. So this is just for a note for style convention. It would be fine if we had it without the question mark, but for style, anytime a variable or a function returns a Boolean, we write a question mark at the end of it. Just a style thing. Okay. So what am I trying to get at? I'm trying to get at the point that we are creating our own data types. And then we can have functions that work on these data types. We have functions that work on strings. We can have functions that work on students. Okay? Okay. So when we write this defined struct line, Dr. Racket provides us with 3 functions. Okay? Dr. Racket says, if you're going to create a data type, we will give you 3 things to help you work with that data type. Okay? So, well, I already went over this last class, but just to formally introduce it again, a structure is our way of bundling several pieces of data together. And we saw that. We saw with a student, we bundled a string, an integer, and a natural number all together. And we called it a student. So a structure is our way of bundling a bunch of information together and creating a data type out of it. And then we can create functions that consume and produce the structures that we created. Okay? So let's work with we have the country and the student example, but let's work with another example called POSIT. So in high school, you guys had graphs. that had an x-axis and a y-axis. And any point on this plane was represented by an x and a y value. That's how we represented points on the Cartesian plane. So let's try to define a structure that encodes this plane. We're going to call it a posen. Okay? So a posen is our way of representing a 2D plane. What does it contain? A posen structure will have as its fields x and y. So how would the defined struct line look for posen? If we wanted to do defined struct for posen, it would be define struct posen, and then what would go in here? X and y. That's a posen. It just has an x and a y. Okay? Now, last class, I said Dr. Racket provides us with 3 functions whenever we create a structure. The first one is something called a constructor. Okay? So, we can define a string by doing define x as quotation hello, end quotation. We can define a number by doing define y as 1, 2, 3. We can define a Boolean by doing define z as true. How do we define students? How do we define posens? How do we define these data types that we're creating? Well, one of the functions that Dr. Racket provides us is our way to define the data types that we create. And that's done through a constructor. So anytime you have a data type called whatever, so in this case we call it posen, Dr. Racket will provide us with a make-posen. Okay? So let's just do this on the laptop just to see what's happening. So we can do define struct. Well, let's just do student, name, age, and gender. I'm not going to write the comments for now. We'll do define struct posen x, y. Or run this. So posen is actually built in to Dr. Racket. I'm just going to call it posen 2 because posen is a structure that's actually built into Dr. Racket. The name doesn't actually matter, but we're just going to call it posen 2. Okay? So the constructor is something that all it does is it starts with make and then dash and then the structure name. So we can do make dash posen 2 and then the fields it takes, the arguments it takes is the arguments that you need to define what a posen is. So how do we define a posen? We need an x and a y value. So this make posen, it takes in an x and a y value. So we can say 5 and 6. And that gives us a posen that's at position 5 and 6. We can do make student. What would be the first parameter I have to pass in here? A string for the name. So we'll say Wasif. Age is the next parameter, right? Because a student has a name, an age, and a gender. So now we're going to pass in an age. I just turned 25 recently. Then we're going to pass in a gender. Okay? And I am a male. It's a symbol. Okay? So that's a student. Make student Wasif. Okay? And we can actually define these as variables. So we can do define x, or define variable 1 as make posen 2, 5, 6. And we can do define var 2 as make student Wasif 25 male. And then, And then when we run this, we can say, what is var1? It's a posen. What is var2? It's a student. So that's the constructor. The constructor lets us create our own data. We could create strings too, except creating strings was really easy. All we had to do was define x as hello. And that created a string called hello. Okay? We could define y as 1, 2, 3. And then y was 1, 2, 3. So creating number strings and these basic data types, they were really easy. But creating data types for which we are defining ourselves, we need this make dash whatever. Make dash student, make dash posen, make dash whatever your structure is. Yeah?
I'm not sure if you're gonna talk about this like going on, but like because if you put instead of like the symbol, you put another number or just give another number, you just have to like to define it. You have to say in the comments that it has to be a symbol, or is there another way to say that if it doesn't put a symbol, it should be an error?
No. So essentially, I'll repeat that after, and I'll talk about it after. Yeah. So don't worry about what he asked. I will talk about it after. So one other thing I want you guys to see is make student. What if I passed in just Wasif? What would happen here? It's an error. It's an error. Because the function make student takes in 3 parameters. It takes in a string, a number, and a symbol. So make student expects 3 arguments, but found only 1. Make sense? Okay. So the first function we saw was how do we create the structures, the data types that we're defining. Okay? The next function is something called a selector. Okay? And the selector lets us access different fields within our structure. So with Posen, we have 2 fields. We have X and Y. So Dr. Racket will provide us with 2 selectors. One for the X field, one for the Y field. For our student structure, how many selectors would we be provided by Dr. Racket? 3. We will get 1 selector for the name, 1 selector for the age, and 1 selector for the gender. Okay? So, what does a selector do? Well, look at the contract for these selectors. Where's my notes? Look at the contract for these selectors. Posen-X consumes a posen, and it produces a number. Okay? So let's see what happens. If we do var1 as make posen 5, 6, we can do posen-x of var1. And remember, the contract for var1, it consumes a posen. This is very, very important. Let's actually go back to it. Remember, in the contract, we're specifying what data types we are consuming and producing. What data type are we consuming? We're consuming a new data type. We created this one. We created a data type called posen, and now we're consuming a posens. Just like before, we had data types like strings and numbers, and we consume strings and numbers. We're now consuming posens. Okay? So the data type, or the contract for posen-x is it consumes a posen, and it produces a number. What number does it produce? It produces the x coordinate of the posen. So if I did posen-x of var1, what would I get? We would get 5. Because posen-x, it consumes a posen. var1 is a posen. And it'll produce, wait, what? You guys are smart. You guys are smart. Good, good. I like it. I like it. I like it a lot. Because our structure is not called posen. Our structure is called posen2. So it's posen2 dash x of var1. Does that make sense? Because our structure was not called posen. Our structure was called posen2. And that'll give us 5. Okay? What about student dash name of var1? Error. Variable 1. So wait, student dash name, what does this function consume? It consumes a student. Is var1 a student? No, it's a posen. Student expects a student given a posen. What about student dash name of var2? Well, it just gives you the name field of the structure, of the data type. Does that make sense? And we have 3 of them. We have student dash age of var2, student dash gender of var2. Okay? If we try anything else, student dash anything else, like name, or even if I did name with a capital E, I did var2, it would be like name is not defined. Because name is not defined. It's N-A-M-E, lowercase. But now if I wanted to add another field here, say blah, 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 blah. Okay? If I ran this, well, first of all, I will get an error. Because var2, this make student now, it consumes 4 parameters, but I've only passed in 3. It consumes a name, an age, a gender, and a blah, blah, blah. And I have not passed in a blah, blah, blah. So we have to pass in a 4th parameter here. Let's just pass in, I don't know, hello. Okay? Now it'll work. Because make student is now a function that consumes 4 parameters and not 3. And now we can do student dash gender of var2, and we can also do student dash blah 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 of var2. We get help. Does that make sense? Yeah? So yeah, good question. The question was, can the data type that's produced, does it have to be just a built-in data type, or can it be something that's that we created? And it can be something that we created. And I'll show you an example. So let's just say name, age, gender, and then this variable can be, let's just say, what's a good compound? What do people have? So like, what would be a good example? Like hair. Okay? Now, for here, we'll actually define the actual. So name is a string, str. Age is a nat. Gender is a symbol. But now, watch what we're going to do. Hair has many properties to it. Hair can have the color, the length, and many other things. So we can define struct hair as length and color. Okay? And then we can say hair is a hair. Okay? And then we have to define what a hair is. So, and actually here, so you know how I said this is not actually how you define a structure? I'm going to go into how we actually define a structure now, because it is important. We have to say student, it is a make student, str, nat, sim, and hair. Okay? And then technically hair is right now is not defined. Because hair up here is a lowercase. So to define what a hair is, we have to say hair. A hair is a make hair, and then length can be nat, and then sim. Okay? And now, technically, this would work. If we tried compiling this, if we tried running this, this would work. But this would be wrong. Why would this be wrong? The reason this would be wrong is because this var2 disobeys the contract for what a student is. What is a student? A student is string, nat, sim, and hair. Hello is not a hair. Hello is a string. So this is wrong because this fourth parameter of var2 disobeys our contract. It needs to be a hair. What is a hair? A hair is this. So let's define that. We'll define hair1 as make hair nat, so let's just say like I don't know, 50, and then black. Okay? And then this can actually be hair1. Okay? So I actually didn't want to talk about this right now, but it was a good natural progression into it. What this is a structure within a structure. Okay? So now we can do student dash hair of var2. What would this return? A make hair. It would return us a hair data type. Okay? We can do hair dash color of student dash hair of var2. So this will return us this. Then we're going to do hair dash color on this thing. And hair dash color on this thing is going to return us black. Does that make sense? So these are selectors. A selector is our way of accessing the different fields